Welcome. Today we are looking at modern physics with a special focus on radioactivity. This is topic 9 in your SS2 physics series. This topic is often tested in your examinations. Pay close attention. Let us begin. First, let me explain what radioactivity is. Radioactivity is the spontaneous emission of radiation from the nucleus of an unstable atom. It is a nuclear phenomenon. It is not affected by chemical reactions. It is not affected by temperature or pressure. Radioactivity was discovered by Henri Becquerel in 1896. He discovered that uranium compounds emit radiation. Marie and Pierre Curie also studied radioactivity. They discovered radium and polonium. Understanding radioactivity is essential for understanding nuclear physics. It is essential for understanding many applications. Examples include medicine, energy, and industry. Now let me explain the types of radiation. There are three main types of radiation: alpha particles, beta particles, and gamma rays. Alpha particles are helium nuclei. They consist of 2 protons and 2 neutrons. They have a positive charge. They have low penetrating power. They can be stopped by paper. Beta particles are electrons. They have a negative charge. They have moderate penetrating power. They can be stopped by aluminum. Gamma rays are electromagnetic waves. They have no charge. They have high penetrating power. They can be stopped by lead or concrete. Understanding the types of radiation is essential for understanding radioactivity. Now let me explain the properties of alpha particles. Alpha particles are helium nuclei. They have a mass number of 4. They have an atomic number of 2. They have a positive charge. They are emitted by heavy nuclei. They have low penetrating power. They can be stopped by paper. They cause ionization. They are dangerous if ingested. Understanding alpha particles is essential for understanding radioactivity. Now let me explain the properties of beta particles. Beta particles are electrons. They have a mass number of 0. They have an atomic number of -1. They have a negative charge. They are emitted by neutron-rich nuclei. They have moderate penetrating power. They can be stopped by aluminum. They cause ionization. They can penetrate skin. Understanding beta particles is essential for understanding radioactivity. Now let me explain the properties of gamma rays. Gamma rays are electromagnetic waves. They have no mass. They have no charge. They are emitted by excited nuclei. They have high penetrating power. They can be stopped by lead or concrete. They cause ionization. They are very dangerous. Understanding gamma rays is essential for understanding radioactivity. Now let me explain the nature of radioactive decay. Radioactive decay is the process by which an unstable nucleus emits radiation. It is a spontaneous process. It cannot be controlled. The nucleus changes into a different nucleus. This is called transmutation. Alpha decay reduces the atomic number by 2. It reduces the mass number by 4. Beta decay increases the atomic number by 1. The mass number remains the same. Gamma decay does not change the atomic or mass number. It only releases energy. Understanding radioactive decay is essential for understanding nuclear physics. Now let me explain half-life. Half-life is the time taken for half of the nuclei in a sample to decay. It is a characteristic of each radioactive isotope. Different isotopes have different half-lives. Some have short half-lives. Some have long half-lives. The half-life is independent of the amount of substance. It is independent of temperature and pressure. The formula for half-life is N equals N0 times 1/2 to the power of T over T. N is the remaining amount. N0 is the initial amount. T is the time. T is the half-life. Understanding half-life is essential for understanding radioactive decay. Now let me explain the decay constant. The decay constant is the probability of decay per unit time. It is represented by lambda. The decay constant is related to half-life. The formula is lambda equals 0.693 over T. Lambda is the decay constant. T is the half-life. The activity of a sample is the number of decays per second. The formula for activity is A equals lambda n. A is activity. Lambda is the decay constant. N is the number of nuclei. Activity is measured in becquerels. Understanding the decay constant is essential for understanding radioactive decay. Now, let me explain nuclear reactions. Nuclear reactions are reactions that involve the nucleus. They include radioactive decay, fission, and fusion. Fission is the splitting of a heavy nucleus. It releases energy. Fusion is the combining of light nuclei. It also releases energy. Nuclear reactions release large amounts of energy. This energy is called nuclear energy. Understanding nuclear reactions is essential for understanding nuclear physics. Now let me explain nuclear fission. Nuclear fission is the splitting of a heavy nucleus. It occurs when a nucleus absorbs a neutron. The nucleus becomes unstable. It splits into two smaller nuclei. It also releases neutrons and energy. The energy released is large. Fission is used in nuclear power plants. It is also used in nuclear weapons. Uranium-235 is a common fissionable material. Understanding nuclear fission is essential for understanding nuclear energy. Now, let me explain nuclear fusion. Nuclear fusion is the combining of light nuclei. It occurs when two light nuclei combine to form a heavier nucleus. It releases energy. Fusion is the process that powers the sun. It requires high temperatures and pressures. Fusion produces more energy than fission. It does not produce long-lived radioactive waste. Fusion is a promising future energy source. Understanding nuclear fusion is essential for understanding nuclear energy. Now let me explain the applications of radioactivity. Radioactivity has many applications. In medicine, it is used for diagnosis and treatment. Radioactive tracers are used for imaging. Radiation is used for cancer treatment. In industry, it is used for testing and measurement. Radioactive sources are used for thickness gauging. In agriculture, it is used for pest control. Radiation is used to sterilize food. In energy, it is used for power generation. Nuclear power plants use fission. In research, it is used for dating and analysis. Radiocarbon dating is used for archaeology. Understanding the applications of radioactivity is essential for understanding modern technology. Now let me explain the hazards of radioactivity. Radioactivity can be hazardous. Radiation can damage living cells. It can cause mutations. It can cause cancer. It can cause radiation sickness. Exposure to high levels of radiation can be fatal. Protection is essential. Shielding is used to block radiation. Distance from the source reduces exposure. Time of exposure should be minimized. Safety protocols are essential. Understanding the hazards of radioactivity is essential for safety. Now let me explain the uses of isotopes. Isotopes are atoms with the same atomic number but different mass numbers. They have the same chemical properties. They have different physical properties. Radioactive isotopes have many uses. Carbon-14 is used for dating. Iodine-131 is used for thyroid treatment. Cobalt-60 is used for cancer treatment. Phosphorus-32 is used for research. Understanding isotopes is essential for understanding radioactivity. Now let me explain radiocarbon dating. Radiocarbon dating is used to determine the age of organic materials. It uses carbon-14. Carbon-14 is a radioactive isotope. It is produced in the atmosphere. It is absorbed by living organisms. When an organism dies, carbon-14 begins to decay. The half-life of carbon-14 is 5,730 years. By measuring the remaining carbon-14, the age can be determined. Radiocarbon dating is used in archaeology and geology. Understanding radiocarbon dating is essential for understanding dating techniques. Now let me give you sample exam questions. Define radioactivity. Radioactivity is the spontaneous emission of radiation from the nucleus of an unstable atom. State the types of radiation. Alpha particles, beta particles, and gamma rays. Explain the difference between alpha, beta, and gamma radiation. Alpha particles have positive charge. Beta particles have negative charge. Gamma rays have no charge. Define half-life. Half-life is the time taken for half of the nuclei in a sample to decay. State the formula for half-life. N equals N0 times 1/2 to the power of T over T. Explain the applications of radioactivity. Radioactivity is used in medicine, industry, agriculture, energy, and research. Let me summarize. Radioactivity is the spontaneous emission of radiation. There are 3 types of radiation: alpha particles, beta particles, and gamma rays. Radioactive decay is a spontaneous process. Half-life is the time for half of the nuclei to decay. Nuclear fission is the splitting of a nucleus. Nuclear fusion is the combining of nuclei. Radioactivity has many applications. It is used in medicine, industry, and energy. Radioactivity can be hazardous. Protection is essential. Understanding radioactivity is essential for physics and technology. Practice these concepts. When you have them down, move to Topic 10.